So for this practical, okay, we are going to take this the pressure vent system, right? That is a component for static analysis. Okay, so let us see the first theory, right? The steps for doing this analysis, and then we are going to do the analysis on the workbench. Okay, so the goal of this analysis, right? Why we are going to do the analysis is that in this workshop, actually, a high pressure vent assembly is analyzed for stress and deflection. Okay, so some of the results from the analysis will be difficult to interpret if all bodies are active during the post processing. So our goal is to isolate the parts of model and use some of the advanced workbench mechanical features for the post processing. Okay, so we'll take one by one, and then we are going to do the analysis. Here are the some assumptions that we are going to make for this, we can say, the analysis. We will assume that gas is being vented through the inlet pipe into the expansion chamber. Inside the chamber, the pressure drops to 20% of the inlet pressure. Actually, this is actually a modal, right? This is a pressure vents, right, system. You can see here this the gas is going through this channel, or we can say tubes, and here the utility will get released. So the pressure drops is up to 20% of the inlet pressure. The expansion chamber is rigidly mounted to the inlet. Thus, we will leave this contact region defined as a bonded. All right. So, what are this contact between this? We can say the exhaust and this pipe. Okay. So that we are going to make as a bonded. The support bracket allows limited movement to the pipe, so no separation contact will be used here. Right. So this support. This is actually a support model. Right. Support. We can say bracket. So the next, the inlet pipe and bracket are modeled using structured steel, while the expansion chamber is polyethylene, right? So you can see here the different materials are used for the different systems or the parts. So you can see that inlet pipe and bracket are modeled using a structured steel. That means this inlet, you can see here, this inlet pipe, right? And this bracket is actually a structured steel, and this we can say the expansion chamber is a polyethylene, right? Okay, so material for this expansion chamber is a polyethylene. So these are the different materials can be taken for this system. Okay, so this is what actually the parts and the names of different parts are shown in the diagram. So this is actually for our pressure vent system. So this is the expansion chamber, then this is a support bracket. Here there is no separation contact. Okay, then this is a bonded contact at this, you can see here, this is inlet pipe. Okay, so now you can see the steps are given here, right? To do the analysis, that is, you can select the first the um, units, right? So we are generally taking up the matrix. Okay, the next steps, that is, select the type of analysis, that is we are going to do the static analysis. So that's why here the analysis type is selected as a static structure analysis, you can see here. Okay, the next step is go to the engine data, right? As all of you know, or all of you are aware about this. Okay, so you have to just click on the engine data, right? In that, what we are going to do, what is actually, what is the purpose of engine data, right? What are the steps, actually, why we are doing, just selecting that engine data, right? What is the purpose of engine data? Just unmute yourself and let me know what we are doing actually in engine data. I want the answers from your side. Let me know that what are we are actually doing in the engine data. What we are doing in the engine data. Unmute yourself and just let me know that this is your static structure. Might be this workbench window is visible for you. This is a static structure option, that is module we have selected here. We are just going to click here on the engine data. So what is the purpose of engine data? Actually, what we are doing in this engine data? Can anyone just elaborate this? Suek, Akanksha, Chetan, Priya. What we are doing in the engine data? Have you attended last practical? Yes, Priya, you are saying about the materials. That means material selection part. Is it right? Or adding a new material like that? Okay. So remember that in the engine data, right? We are going to select the material, right? We are adding the new material if we require. Okay. So this is the purpose of actually the engine data. Okay. And next, in engine data, actually we are selecting the different materials, right? Here we require the different two materials. That is the one is we can say the structure steel, and another is polyethylene. Okay. And next, we are after selecting these materials, right? You can select just add on this material. This is a 3 number step. You can see here from general materials, click on the plus sign, right? Then next to the polyethylene, because we have to select the polyethylene material. Then that material is actually added to the your current system. Then you can go to the return project, right? And then after that, we can go for the import geometry, right? That means for the adding new geometry to the system. Or otherwise you can draw, or you can just model the geometry in new geometry option also. That is in geometry option in the ANSYS itself also. It's depend upon you, right? If the geometry is available with you, you can just directly import that geometry. That is the step number 5. Then step number 6, you can see that there is one option, that is model option. You can see here it is highlighted actually, right? So when we click on that model option, right, you are again getting the some sub steps below that, that is setup, solutions and results, right? So can anyone tell me what actually we are doing in the model option, right? It's good when it is that means if you unmute yourself and you can speak, right? That will be a very comfort for me, because your chat box is not visible for me at this moment. Otherwise I want to just minimize this, and then I can see the chat box, right? So it's a request for you, just unmute yourself and you can discuss with me. What are we are doing in the model option? Here in this model option, because now at this moment it is not we can say active, because here the geometry is not created, right? But if we import the geometry, right, if we add the geometry in that, then it will be activated. But yes, I want to know that what actually we are going to do in this model option, right? Or what are the steps we are completing in the model option? Yeah, remember that in model options we are going to do the meshings. We are going to do the solving the problems, right? We are going to apply the boundary conditions, right? We'll solve these problems, right? And then we can find out the, we can do the post processing also, right? So all these steps after the geometry creation, that is meshing, applying the boundary condition, solving the problem, finding out the different values of the stress strain, right? That is related parameters, or we can do say the post processing states, can be done in this step. Okay. The next, that is again you can set the units, right? And you can do for the next, that is a material selection part in the model, right? When we open this model, right, you may observe that these types of steps are there, that is 4, 5 and 6. 4 is the model, 5 is the static structure analysis, that is boundary condition we can apply here, right? And in the 6 we can go for the post processing part. Okay. So you can see here in right 8 number, we are going to change the materials, as we have the condition that for expansion chamber the material is polyethylene, and for this bracket and for the tube the material is structural steel. So we are going to just select these two materials, right? So here you can just select the part, right? And just you can see in the material there is an option that polyethylene or structural steel. According to your requirement you can select the material, right? Okay. Then next, for this tube the material is actually sorry, it's a structure steel that we have selected. Now next is about the connections, right? In the previous practical session we have seen only one component, right, or one system. There is no any other than that, means assembly is there, right? There is no any second material is there, or second system is there, or component that is connected to each other, right, to the first one. So here you can see that modify the bracket to pipe contact behavior, right? That means here we have to mention the contact now. Okay. So in the connection itself in the model, you can see itself in the model there is option like connections. So in the connections, it will show that the actual contacts, right? When where how that means wherever there contact between the two parts in the your model, it will shows that contacts, right? So here there are two contacts at this position and at this position. So that's why here contact region 1 and contact region 2 are visible for us. So according to the your requirements, according to the problem, we have to select the type of contact. It may be a non-separation type, it may be a frictionless, it may be a rough or frictional, right? Okay. So then after selecting the contacts, you have to go for the next part, that is a meshing, right? You have to just click here on the mesh, just go for the right click, right, and do the meshing. Automatically with the workbench will do the meshings, right? And after that you have to go for the boundary conditions, right? Now you know that this is a pressure vent system. Obviously this is an inlet, right? And this is actually this expansion chamber is the exhaust. So obviously the gas is coming, that means going through this pipe, right, to the towards this expansion chamber. So obviously this internal part of this pressure pipe, or we can say the this piping is subjected to somewhat pressure. So let us assume that is pressure is 1 megapascal, right? So that is applied. So let us select the type of loading is pressure here. Select the internal faces and let's say 1 megapascal, right? So that means all these internal faces of these pipes are subjected to stress, or we can say pressure of 1 megapascal. Okay. So select the 5 interior surface of the pipes. You have to select these 5 surfaces of the pipes. Okay. Because this one, second, third, fourth, and fifth. Okay, and then you have to apply the pressure. The next, after this, for expansion chamber, right? That this is expansion chamber, because in the problem it is given that we will assume that the gas being vented through the inlet pipe into the expansion chamber. Inside the chamber, the pressure drops to 20% of the inlet pressure, right? So whatever the pressure inside this chamber is actual 20% drop of the inlet pressure. So that's why we are taking here as a 0.2 megapascal, right? Because here the pressure is we have taken as a 1 megapascal, right? So here it is we are taking as a zero point 0.2 megapascal, the pressure drop here. Okay, 20% of the inlet pressure. So that's why zero point 0.2 megapascal the pressure apply here inside this. There are three phases again. This is one cylindrical, this phase, and this. These are the three phases. Then next apply the constraints to the pipe. right? We are going to apply the constraints to these pipes. Okay, so select the end surfaces of the pipe. Okay, so here it is a fix actually, which is connected to some another part, or we can say the engine exhaust. So that's why this is A is a fixed support, right? Okay, then this is also bracket where the nut and bolts or screws are fitted. So that's why here also we are taking as a fixed support. You can see here, right? Okay, the next, this is also one of the where we are going to rest this bracket to somewhere, right? So we are going to select it as a frictionless support to this part. Then next we are going to solve this problem, right? After solving this problem, we are going to find out the stresses and deformation, right? That is deformation, total deformation, that is in XYZ direction, right? And next stresses, that is the equivalent for minus stresses. So here we will get the final results for the stress, right? Here and here for the deformation, you can see here. So this is our final results for this experiment, right? Okay, so that is a what our practical is regarding the stress and deformation, stresses and deformation. Finding the stresses and deformation of any mechanical component, right? I will just show you that. Okay, so stress and deformation analysis of any machine component consisting of 3D elements using FEA software. So here the component, machine component, we have taken it as a pressure vent system. Okay, might be all of you are aware about this pressure vent system. That is just what nothing but a silencer of an we can say engine. All right. Okay, so where the pressure drop will takes place, right? And we are just doing the study of the stresses and the deformations in that exhaust system. Okay, is it clear what we are going to do in today's practical session? Just let me know first, and then we'll start for the practical. Akanksha, Chetan, and Priya, Suyog. Yes. Okay. Okay. So we will start to do the practical, right? Now this is what the actually I'm starting with initial, right? I will delete this all this clear out the workbench part. I hope that the workbench is visible for you, right? The software. Okay. Now let us select the static structure as our, we can say module, right? You can see here the steps are given. That is first is a selection of the module, that is static structure. Then second is what going to that is finalizing the materials, that is engine data. So let us select the material. By default, the structure still is there, right? But we have to add the polyethylene also. So we will click on the general materials, and in that, let us see where it is a polyethylene is there, right? You can see here the polyethylene, right? So you have to just click the add on that. So that material is also added in our library. So we will say that return to the project, right? And update the project. So these two materials are added in our library. Now let us go for the go for the geometry, right? So we have to import the geometry, or otherwise you can draw this geometry. But we'll try to import that if available with us. So actually, this geometry is available with us. So I will just try to import that. Okay, I just imported. You can just right click here and you can browse that, and you can just select the type of drawing. It is a pressure system XC. So I just import. Now, after that, importing this material, right, this model, you can go for the next 6 number step, that is model step. Let's say, I will just click here. Okay, now you can see here, right? I think this is visible for you, right? So you can see here this pressure vent system model is exported here, and now this is available with us. Okay, so you can go for the geometry option, right? You can see the next step, right? After importing this, you can go for the numbers set the units, right? Let's say it is in metric. You will check that the units are in metric, right? So let us say in kg Newton, right? Let's say it should be kg Newton. Okay. So after that, let's see that the 8 number step, that is you can select the materials, right? That is 8 number is what change of materials on the expansion chamber. Actually, when we select this, right, this is actually a pipe. You can see here green color. The material is for that pipe is structure still here. It is highlighted. The next part is you can see the expansion chamber, that is green color. It is highlighted. So here you can see the material is structure steel, but we require the material for this expansion chamber, right? For this expansion chamber, the material should be an polyethylene. So just we'll click here on this arrow, and just let's say it is an polyethylene, right? So the material for this expansion chamber now, right? Okay, material for this expansion chamber is polyethylene. The material for this piping is structural steel. The material for the bracket is again a structural steel. It is given. So now we have successfully changed the material for the we can say expansion chamber as a polyethylene. Okay. Now let's go for the connection. All right. Here there is no need to change the coordinate systems, or we have to not require this part. Okay. So go for the connection. You can see here the steps is also given, right? And the next 9 number step is modify the bracket to a pipe contact behavior. Then highlight the contact region 2 and in the connection branch. So in details window, change the contact type to no separation right here. So for this, we'll check in this. So here you can see the contacts are there. Just when we click on this contact region, you may see here, right? That is, it is I think visible for you. So it will shows the contact, actual contact, right? Where it is. So for contact region 1, you can see this is actually a contact between this. We can say uh, exhaust chamber and the pipe. And contact 2 means what? The contact between this pipe and bracket here at this point, right? Okay, so let's see that what are the conditions. Actually, we have to change the contact region 2, right? And that is no separation. Okay, so let's see for this contact, and let's here we will make it as not bonded. It is no separation contact. Okay, so just here the contact is changed. We have changed it is to the no separation. The next, let's see, go for the applying the boundary condition. Before that, we will make it. We will do the mesh it, right? Let's say the generate mesh here. Just here to right click here and just select the generate mesh option. Okay, now here you can see the meshing will be done, right? But it is not up to the mark. So we'll go for the changing the size of the meshings, right? We'll go for the medium mesh, and let's say the update. So we'll try to reduce the discretization errors, right? Now here you can see, right? I will just make it as again a fine, and just I will update that. All of you are aware about this. Okay, now let's see, we'll check, we will go for the selection, that is sorry, applying the boundary condition. So here the boundary condition is what? We are going to apply the pressure inside this. It is actually 1 megapascal. So let's say we will apply the load, that is in terms of pressure, right? So let's select the faces now. Okay, so this is one of the face, right? Here let's say we will hide this part also at this moment, just for our sake of we can say the convenience. Here also hide body. Okay, Now we are going to प्रॅक्टिकल चालू आहे म्हणून सांगा विचारलं तर ऑनलाईनच आहे ना. So again, this is another second phase. We'll just select that also. Then we will go to, let's say, hide this body. Oh, just so where is that pressure actually? Okay, this internal face. Okay, then this elbow, this face internal. Then this face and this elbow. So you can see here the five faces we have selected. Okay, so these are the in red colors you can see. Okay, now the pressure is how much it is acting. It is 1 megapascal, right? That is in normal to that plane. So normal to 1 megapascal we will say, right? So that is on these internal surfaces. Then again I will just make it as show body, right? Then show body. Now I will just hide this pipe. Okay, and I will select the internal faces of this also, because in this, for this chamber also the pressure is acting, right? So load pressure, it is in for this surface, then for this surface, at this surface, right? And at this surface also, because these are the surfaces, right? So you can see apply, it is 0.2 megapascal. Okay, again it is normal, you can see here. Okay, now this bracket is fixed, right? Here the fixed support is there, so we'll go for the part of fixed supports. Fixed support, I will just show body. So where is fixed support, this surface is fixed. Okay, so let's say apply. Okay, then another is what you can see the after applying the fixed support to this, next is applying the constraints, that is for this bracket, right? It is a cylindrical support, because why the nut or bolts are sorry, bolts are there inside this, so here we are getting a, we can say, a cylindrical support. So that's why we are applying here again load, sorry, support. It should be a cylindrical support, right? Where at this region you can see here the actually bolt is there. So let's say apply. Okay, then after that, here there is a frictionless support. Okay, here there is a frictionless support because it is rested at some point, right? So we'll go for this frictionless support for this space, apply. Okay, and then you can go for the solving this problem. So solving for the stresses and solving for the total deformation. Just say solve. Okay, so here you will get the stress and deformations, right? Whatever this, you can see how the stresses will be developed, because this is actually a pressure vent system, right? That internal surface of this pipe are subjected to a 1 megapascal pressure, and here I added zero point 0.2 megapascal. So this is actually how the pressure will be developed, right? How the stresses will be developed due to that pressure in the body. You are going to see, right, in this. Then here also you can see the deformations. Obviously the deformation will be here because this is actually a fixed support, a fixed pipe. So this is actually a deformation diagram. You can see here, right? Here it is 1.41 we are getting, and how much it is we are getting as a 1.9, right? Here if we go for the stress we are getting as a 18.69 megapascal, and in this it is getting as a 18.09 megapascal.